Okay, question 3 on acidity constants. Here's another one. We have a 0.031 molar solution of a weak monoprotic acid, and it has a pH of 4.69. We want to know what the Ka value for this reaction is. So I'm going to start off with, it's a monoprotic acid, so I'm just going to give it a name or give it a symbol as being HA, because A for acid and H because it's monoprotic, it's only got one hydrogen. This is going to dissociate with water, obviously, to form H3O positive and A negative. Just does, all right, because monoprotic, it just dissociates. That means we can write a Ka expression. So our expression for Ka is equal to concentration of hydronium times concentration of that divided by concentration of our initial acid. We're dealing with pH, so I'm going to write down my 3 pH equations. I'm going to write down concentration of hydronium equals 10 to the negative pH. I'm going to write down concentration of hydronium times concentration of hydroxide equals 10 to the negative 14 at SLC. And I'm also going to write down that pH equals negative log to the base 10 of hydronium. So therefore, I've got those written down. Let's go have a look at this question here. So it's very similar to question 2. It's actually exactly the same as question 2. We're going through the same process. But I'm going to work out my concentration of hydronium. Here, it's going to be hydronium equals 10 to the negative pH, which equals 10 to the negative, what's my pH? 4.69. I'll do this in my calculator because I don't like having decimal points in my powers. Negative 4.69 is 2.04 times 10 to the negative 5. All right, so that's there. We assume, as we know, that all of this came from our acid, so therefore these two are equal, so that's going to be equal to the concentration of negative. And we also assume that concentration of HA initially equals concentration of HA at equilibrium, because it's a weak acid. We assume that. And therefore, my Ka becomes 2.04 times 10 to the negative 5 squared divided by whatever my concentration was, 0.031. You can't see it, here it is. So therefore, this equals, on my calculator, I square that, answer squared equals that, divided by 0.031 equals a very small number, 1.34 times 10 to the power of negative 8. It's a very small number, all right, and that is in molar. But as you know, it's a weak acid, so expect it to be pretty weak, and it's a pretty high pH for an acid, for any type of acid anyway. So it's obviously only really partially ionizing. So makes sense, really. This is your acidity constant for this reaction. All right, last question on acidity constants. Let's go have a look at this one. A monoprotic acid, HA, has a Ka value of this. That should have a molar next to it as well. Has a Ka of that. Calculate the percentage dissociation. Calculate the percentage dissociation of HA in a 0.1 molar solution. Very good question. Percentage dissociation. I like that one. All right. HA plus H2O forms A negative and H3O plus, as we know. What we want to work out is the percentage of this which breaks apart into that. So we want to know how much, or percentage dissociation, equals concentration of our conjugate base divided by the concentration of our acid times 100%. So this is going to be our percentage dissociation. The amount of this divided by the total amount times 100. Alrighty, we also got given a Ka value, so I'm going to write down my acidity constant is equals concentration of A minus positive divided by concentration of HA. Alrighty, there it is. Now we've got our acidity constant, we've got how we're finding percentage dissociation. You need to remember this idea here. We need to find some values. Obviously we've got a value for our concentration here. We need to find our concentration of A minus. So what we have to do is obviously sub in some values. We've got a Ka value here. I'll go back to blue. So we've got 3.1 times 10 to the negative 7 equals something over 0.1. Obviously that's coming in here. Now our assumptions, we assume that obviously A equals concentration of HA at equilibrium. So that's just assumption there, number one. Our second assumption is that the concentration of A minus equals the concentration of H3O positive. Okay, so therefore we assume that these two are equal. Now, that means we have concentration of A minus squared because these two are the same, so therefore we can go concentration of A minus squared equals that. That means we can rearrange this equation and work out what our concentration of A minus is. So obviously multiply this, we get times 10 to the negative 8 equals concentration of A minus squared. Therefore the square root of this will equal A minus. So 1.3 times 10 to the negative 8. We want to get the square root of that. So square root, our answer is 1.14 times 10 to the negative 4. Alrighty, now we can got this, so that means we've got this one, so therefore we can work out our percentage dissociation. So our percentage dissociation equals 1.14 times 10 to the negative 4 divided by our concentration, which is 0.1, multiplied by 100. Let's do this, divided by 0.1, because that times 100 equals 0.11 percent. A very small percentage dissociation, which you would expect, and what we assumed would be true as well, because we assume that the amount it dissociates is negligible. So really, 99.89% of this acid remains attached with the proton on it. Therefore, we have our dissociation here. That's it. I hope you enjoyed these videos. Hope it's helped you a bit. Just remember, when you're doing questions like this, always write out a little equation here. Always write out your Ka value. If you're looking for percentage dissociation, write down how you're going to find it. And what I didn't do with this equation is I didn't write down my 3 pH things, mainly because I didn't have a pH and it didn't ask me for one, but I should have really written down the concentration of H3O positive equals 10 to the negative pH. I should have written down H3O OH negative equals 10 to the negative 14 at SLC, and that the concentration of, pH equals negative log to the base 10 of concentration of hydronium. I always write those down if I have a pH in the question. I didn't have a pH in this question, so therefore I didn't really write it down. Probably should have anyway, because I know it's dealing with acidity constants. Anyway, hope that helped, and I'll see you, I think the next video I'm going to be looking at is doing stuff on the chemical industry in Australia. So take it easy and have a good one.